Okay, so here we are in Cinema 4D, and as you can see, here we have a bunch of videos of real-life fireworks, and if I press play, you'll see them going. And it's great to have a look at real-world reference when you're trying to emulate or create photorealistic simulations. I think it's essential. Do some research, go get some videos, and just check timing on things. How long are they in the air for? How long do they remain in the air? You know, all the different types as well. So if I jump down to this second one here called a chrysanthemum, you see you get these trails of sparks coming up behind them. I think this is one of my favorite ones. And this is going to dictate how we create our particle system. It's going to influence how we're going to render our particle system. This one here is quite an interesting one. This is called a diadem. And you see how that's got sort of primary and secondary flares going on. And it's also good to check out sort of how these are actually made in the real world, and that'll actually influence how we create them in our scene. So I'm actually going to jump over. Let's have a look at a few more of these. There's a fountain. That's a floor-based firework or a pyrotechnic, I guess. And of course, the principle of these is that not always are they projectiles in the air, but aerial fireworks, aerial shells, are fired up from the ground. They go for some time and then they explode in the air, and you get that beautiful, let me let that play, and you get that beautiful flaring in the sky. So let's jump over to an illustration and we can have a look at the components of a firework, and that'll help us understand what we're going to need for our particle system. So here is our firework shell, it's called, and this is this particular shape is actually a sort of a Chinese style firework. And you can see here we've got the outer casing, and then we have this fuse. So this is actually called the main fuse, and it's also known as quick match fuse because it's insanely quick when it gets ignited. If I hide the outer casing so we can see the insides, and we get a cross section of what's on the inside of this, I'll just run us through the basic process of what happens. So obviously we need to light the firework. So we'd ignite this quick match, usually with an electronic switch, and then almost immediately this thing, it's like an explosive. So it rapidly ignites. It hits into this part here, this chamber here. And this chamber is actually known as the lift charge. So this is what actually lifts the firework up. So obviously we're going to need something that will lift our fireworks or control the motion of our fireworks in our particle system. So obviously they get ignited by this quick fuse. It's got some ignition there, and then you get thrust upwards. It gets thrown up, but also it ignites this thing here, which is actually called a timed fuse. And once that's ignited, you've got a certain amount of time before it hits the center of this firework and everything explodes out the middle. So that's when this thing in the center here gets ignited. This is called the burst charge. So it's a burst of the firework. And then that ignites. And then these things on the outside are sort of what give it the shape. They're called stars. So these little sort of... well, they're circles here, but they're actually cylinders. Well, not just cylinders, they're spheres and cylinders and all sorts of shapes. But that is actually what gives the firework its actual shape. So obviously, there's sort of interstitial black powder as well. That all gets ignited, and you get different effects from different types of stars. So I think we should get into Cinema 4D now. So that's just a quick intro into sort of the names of what we're going to be dealing with. And now for the fun stuff where we actually start playing with the emitters and the particles. Now, we've got to think of a few things, and if I just add an emitter in here, we can think of our projectile as a particle, because what we can do is we can actually have it emit the particle, and over a certain period of time, or after a certain period of time, or at an event, we're going to trigger a spawning emitter to simulate our stars breaking away from the firework. But to do that, we need an initial particle. So to do that, we need an emitter, and this will be our actual projectile. So I'm going to call it. Change its mode or emitter shape to defined emission. I'm going to make the count 1, and then I'm going to name this sort of straight away. So let's call this projectile. And if I press play now, we're going to not see much. In fact, it's quite hard to see at all because it's a small display type. Let's change it to a, let's go for an arrow. That's nice and indicative. Now, at the moment, obviously it's going down along the z-axis. We can make it go to the y-axis. We can either do that using initial direction, or we could rotate the emitter. I'm going to use initial direction. And we can see the arrow is not pointing in the right direction, and that's because we need to always set up our rotations, and that's done on the extended data, general, and then the rotation mode to tangential. And there we go. That allows us to make sure our arrow is pointing the right way. Now, we're firing this up into the air. We obviously need several things here. We need gravity to kind of simulate the forces of the Earth pulling on the firework. So, or whatever planet you might be on. So if I add an XP gravity, we'll see that gravity is immediately in effect, and our poor particle is being squashed right back to the center of the Earth. So that's of course because our initial velocity is way too small. We're only just sort of 1.5 meters a second fighting against gravity of 9.81 meters per second squared, because that's an acceleration. So we need to try and initially outrun that to get our projectile in the sky. And I'll go for 2000, and there you go. We actually get our projectile in the sky. It looks a little boring at the moment. It's behaving correctly, but it's just straight up and down. Reaches its apogee and then comes back down to Earth. But it'll look better if I tilt it here, give it a bit of a trajectory, a nice arc. And there we go. It'll come back down until the end of the sequence. And that's all well and good. And I'm kind of going down this route because I want to show you all the different ways we could do this. Now, that's one way of doing it. Another way would be to have it directable. We might actually want it to follow a specific trajectory, a specific path. So this you could argue that this one is the realistic. You fire it out of the tube, the aerial shell is fired, and it moves along until we decide to explode it somewhere up here. I think that's great, but I also think it's kind of hard to art direct. So if I actually do a trail behind this, if I actually add an XP trail, so we go to our generators and just add a trail, not tail, trail. That might get confusing. Press play and you can see that's our trajectory. That's nice. But what if I wanted it to kind of do a loop-the-loop somewhere in the middle there, or maybe even spell something out or something like that? Well, we'd actually have to have some input and have some control over the projectile. And we can do that using a FollowSpline, or there's a few other ways of doing it, but we're going to go for a FollowSpline. So let's actually draw out a trajectory. Let's do something a little bit crazy. Let's go, I'm going to grab the pen tool and I'm just going to go into the front view here. And let's just start drawing some kind of wacky trajectory. Where's that loop-the-loop? Now this is obviously highly unrealistic. Well, unless it was a kind of a broken firework, I guess. And that's that in that view. That's a bit flat at the moment though. You can see that there. If I move that across there and that around there. There we go. And you can draw any trajectory you like. That's not particularly important at this point. I'm going to delete our trail object. We don't really need that anymore. Let's add our FollowSpline. And then we need to associate the spline with that FollowSpline. Now, the emitter at the moment, if I move our spline away and press play, you saw the particle, it actually jumps to the nearest point on that FollowSpline that it can. Now, our speed of our particle, if you recall, I'm actually setting it here. Now, that's insanely fast right now. We don't need it to actually have any speed, but I'm gonna leave it on for a minute. It's actually moving on its own speed value, but we're going to actually set it to a timed value, so it's very predictable. That's good. It jumps to the nearest point. We could actually set a specific vertex or position along the spline. So we could say 0 position along the spline is where it's going to start always, which is good. I think that's probably the best way to do it. One way to guarantee that this emitter and this particle always end up in the right place, though, I'm grabbing the wrong thing, is to actually align this to the end of this spline. And that's actually thing that we're going to start looking at is actually a rig that we're going to be able to reuse to create our firework. So I'm actually going to add an align to spline. I'm going to throw that on there, and I'm going to have it at 0%, and I'm going to set it to tangential. Oh, and I need to change, I don't need to, but it's currently in initial direction is the Y plus axis. I'm going to set it to Z plus, but I did just set this to tangential in there so that our emitter points along the spline. There we go. So the advantage of this is now, if I deform this spline, our emitter is always going to be at the base of our insane trajectory. Okay. So I might actually make that a bit more sort of straight up. I'm going to reset the PSR of this one. There we go. And away our firework goes. Now this has, we don't, this is emulating our lift, but we don't actually have any particles coming out the back yet. We'll do that in a second. But the one thing it is doing is it's going on its own speed. Like I said before, it's 150 units per second. Now, I don't want it to do that. I want it to be a specific time. I want it to be way more predictable. It's totally fine to use the initial particle speed, but I want this rig to be a bit more predictable in terms of its timing and its explosion stuff. So I'm going to say complete the length in a certain amount of time. And if you say 90 frames, it's going to look very similar because obviously that seemed to be completing pretty similar. But I could then say, let's complete it in 60 frames. And it'll go up, and there we go. And I'm going to set the Bezier spline to uniform, and I'm going to add a bunch of interpolated points. There we go. So next up, I might actually change that to a cubic spline. Cubic splines tend to have that natural sort of curving to them, and they kind of, you don't get as many kind of kinks as you do with a drawn sort of Bezier spline. But I like to mess around with the cubic ones, so let's this is a really very wacky trajectory. If anyone made a firework like this, it would be kind of horrifying for the audience as it comes back towards them and the ground. But anyway, let's do that because it's fun and it's making a point. And I want it to kind of go straight up at the end, actually. That's kind of nice. Cool. So here we have our controllable projectile. I might actually call it I might rename it shell, or aerial shell, actually. That's exactly the term we should be using. Let's take our spline, and I'm going to call that one trajectory. I like to add a suffix. You might have seen in the other projects. That's just my naming convention. You can name them whatever you like. But the principle is, this is now our lift system. So if I move our emitter, if it was sort of attached up here, which would be kind of a weird place for it to be attached, you can have it start there, and the emitter will always start from that point. So I really like that. There's other ways you can create this kind of setup where you actually have a selection on the spline, and then you can emit from that selection on the spline. I just prefer this one. It's for this particular task, I think it's perfect. Okay, so what do we need next? We've got our lift system. We're using our imaginary lift charge burning all the way up here, but what happens when it gets to the top? It doesn't seem to do anything. It just kind of starts to fall back down, and it even leaves the spline. So what I want it to do is I want it to burst at this point. So for that kind of system, we need a question and action setup. Oh, actually, even before we go into that, I did mention being able to have sort of sparks and burning filings, metal filings coming out the back of the main aerial shell from its lift charge. So we'll do that first, and then we'll go back to the timed fuse stuff. Okay, so I'm going to start getting organized, because the more of this system that we build, you'll see that we need the system object to help us organize it. And we actually have this beautiful button here called the XP system sort, and that'll just chuck all of our existing XP objects in the scene into our system. Now the spline trajectory is not an X-Particles object, so it's left outside, which is obviously getting quite lonely, so we'll put that in there. Make sure it's all working, no problem. That's excellent. Okay, and keep saving, of course, that's always a good idea. Now, what else have we got here? Make sure we could we could do only modifiers in the same system. Now, I like to do that either in the system object, or you can actually set it up here, or you could do it in both if you're really kind of paranoid that it's not going to do it. But all it does is it checks on that when, as long as the emitter's in the system at the time, when you press that button, it'll activate it on there as well. So that's good, just in case you had, say, multiple fireworks in the same scene. That's called foreshadowing, I believe. So let's press play. Just checking it out. That's all good. Okay, so like I said, we're going to have some tail fireworks for our main projectile aerial shell. And what we need to, of course, to add more particles to a scene from a main particle is a spawning object or a spawning modifier. So let's add one of those, and we could grab it from our modifiers null here. These are just nulls. They're just nicely, they have nice icons to them. So xpSpawn, there's no particular worry about the order of these. These do execute top to bottom, but let's just go for our xpSpawn object. And we've got this handy button here called Add Spawning Emitter. Now, if I press play now, we're going to get some particles falling off our alpha main projectile. Now, I don't know if you can see, but some of them are actually getting stuck on the actual the spline there. That's because they are respecting this follow spline. So what I'm going to do is I'm actually going to exclude the follow spline from this. And there we go. We've got our nice particles kind of pumping out the back there. That's kind of looking good. But of course we can make it look even better. So let's go to our XP emitter. I should actually label this as our, well, what should we call it? We can just call it the shell tail. And that's the tail particles. I'm just going to put it under it in the hierarchy. That's not important. I just like to know my primary particles or emitters, and then I have my spawn emitters below those. Let's go to our display tab. Change it to lines. And there we go. We get a bit more of a sort of a motion blur-esque look, which we'll probably be using later when we're rendering. It's good to see because you kind of get an idea of how fast those particles are being fired out. We can increase the number of those particles if we go back to our xpSpawn modifier, and we can pump that up to the full 1,000. You can go way beyond that. We can go to 10,000. That looks perhaps somewhat excessive. We're ending up with some kind of Christmas tree-esque shape there. Let's go to 500. No, let's go to the 1,000. That's nice. If I have variation, it's going to kind of like pulse and sort of randomly emit. That would be a badly made firework, I guess, with an inconsistent lift charge. And at the moment, the actual particle speed is coming from the emitter itself, and they're all firing off in all directions, which is fine, and that works for this scenario. But it's kind of spreading out a little bit too far. And I think we also want to deal with the speed as well. So I'm going to actually grab the emitter tail shell, which is the spawning one. You can see the icon change when we added it into our thing. I'm going to drop it down. If I drop it down to 0, you'll just get a stream of particles falling out the back of the aerial shell. We don't want that. We want them going... That 150 looked all right, actually. Maybe 100. And then let's add some variation into that. So let's add 50. And that's looking pretty cool. All right. And we won't deal with radii just yet. We'll deal with radius when we actually get to the burst, and I'll show you some cool stuff we can do with kind of simulating drag and things like that. Okay. Now, in any kind of natural system, you're going to have a lot more turbulence than this as well. So let's go for some turbulence as well. Modifiers. Motion modifiers and xpTurbulence. This is a common one we'd use. Now, it's actually quite good to have that at the lower part of the stack usually, just so it's the last thing that gets influencing the particles. Not very visible at the moment, and we definitely don't need it affecting the aerial shell, but because the follow spline is dictating where that's going, it doesn't matter at all. So let's have the xpTurbulence. Now I'm going to drop the scale right down. And it's very hard to see it, but I don't think we're seeing any of it at the moment. Let's go to maybe 50 strength. There we go. It's starting to break up. And I want it to be quite a high force because obviously this is a very aggressive reaction in reality. You know, this is burning, it's firing these particles out at high pressure, high speeds. One major thing we haven't thought about here just yet is the fact that these are going on forever. So if I extend the timeline, let's go for something like, let's reset the camera there actually, something like 300, away it goes, and those particles are in existence forever. So, but we don't want that, so let's have them have a finite age. So we're going to set the full lifespan to something like 30. Let's just test that. I'll give it some variation in a second. Maybe even less than that, which is less than a second basically. There we go, fizzling out. Actually, let's go back up to 40 and then we'll have a variance. We'll have a variation of 20. There we go. And those are sort of fizzling out. So we're not getting more particles added to our sim. Awesome. And obviously, because this is a particle system, if I just lift this up off the ground a bit, and we actually added a ground plane, or a plane object, I should say, I add a Collider X-Particles collider tag onto it. Let's leave the bounce quite high. Let's have a little bit more scatter. Press play, and you can see it's colliding with that. It looks awesome. We probably won't have too much collisions. Oh look, the aerial shell's actually colliding as well. That looks awesome. We're not actually going to have too much collision stuff in this system because obviously they're firing up into the sky and exploding up there. But you know, perhaps in fact on the platform that they're going to launch from, you know, there would be some collisions. So we might have that on depending on how heavy it gets. And so that's kind of our lift system kind of done. Now, like I told you when we were looking at the videos, they don't actually always have this tail. So it's nice and easy. If we don't need it, we just turn it off. We could even just turn the spawn object off and then this emitter does nothing. It just adds no particles, or we turn the spawn on and we have our tail. Cool. Maybe I should give them a different color actually on the tail. Now, you saw earlier, I actually excluded some modifiers from, you know, each other. We could be using groups here, and we might change to using groups later on depending on how complex each individual system gets. But for now, I tend to do the excluding early on, and just if it's working, it's working, and we can stick with that. But if it gets too complicated, groups are super powerful, and we'll actually need to move over to them. But we don't know that yet, so I'm going to stick with just this simple excluding because it's not too complex at the moment. Okay, so like I said, let's change the color. Go to our display tab. Let's do a gradient parameter. If I press play now, you'll see as they age, they kind of fade away. That's kind of nice. So we could do a heat gradient. I quite like doing sort of semi-realistic gradients in the viewport. Just kind of helps sell effect and you kind of get a feel for what it's going to look like. If I hit the K on the color picker here, it's Kelvin, which is temperature. It's just nice to get some natural colors from that one. Let's drop the blues out. And let's have that there. Now there's a little trick here. We can actually overbright colors, and this will come into the rendering later on. If you have a gradient, I can hit 300% brightness on the knot, and it'll actually bright to a much, almost goes to white. In fact, if we go high enough, it will actually go out to white. That's kind of a realistic idea of black body radiation, which is another thing we'll talk about when we're rendering. Anyway, I digress. That's our shell system kind of sorted out, and we can tweak settings, like I said, endlessly. So if I drop the speed down, the spread's going to be much less, and you can see actually the turbulence is taking over a lot more. Now, obviously, this is kind of dangerous for the audience and the crowd at the moment as it comes back down and lands on the ground. No one knows when it's going to explode. Well, actually, we know it's not going to explode because we haven't set that up yet. Because that's what we're going to be doing in the next video, where we're going to take a look at the lift, the break or the burst, and also how we're going to shape the stars to form these unique different patterns and different types of firework. And we're also going to start looking a little bit more into the drag system and whether we're going to use an XP drag modifier or a speed modifier with some kind of mapping to give them their natural look. Okay, I'll see you in that video.